Let me begin today's episode with a question that may seem simple, but whose answer could open an entirely new door in the way you think. The question is, what is the sum of 1 plus 2? You'll say 3. Well done. All right, and if I ask you, what is the sum of 1 plus 2 plus 3 plus 4? You'll say 10. Excellent, wonderful. But what if I told you that I want to calculate the sum of 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus all positive numbers up to infinity? What would the result be? You'd say, infinity, of course. I'm adding numbers that never end, so the result must be extremely large. That's obvious and needs no thinking. But my dear friend, the truth is, it does require thinking, and I'll tell you why. In 1912 in India, there was a man named Ramanujan. He worked as a clerk in the office of the Accountant General, and he was deeply passionate about mathematics. It's true that he studied no more than basic arithmetic in school, yet he dealt with mathematics with love. He understood it and enjoyed it as if he were playing with it. He kept playing with mathematics until he reached a solution to the problem I just mentioned. But the result he obtained was extremely strange. The answer, my dear friend, was perfectly logical. The result he reached was negative 1/12. Listen carefully to this number and repeat it with me. Negative 1/12. You might say, didn't you just say we're adding all positive numbers? How can the result be negative? And how can it be 1/12, which is smaller than the smallest number in the series? Be patient, my dear friend. Let's walk step by step. First, let me tell you that there is a concept in mathematics called infinite series. Simply put, you create a sequence of numbers and choose a specific rule by which these numbers progress. You can define any rule you want and give the series a name. The series could consist of decreasing numbers or only odd numbers like 1, 3, 5, 7, or only even numbers like 2, 4, 6, 8, or each number could be the previous one multiplied by 2 or divided by 2, or any rule you freely choose. All of this is possible, but the most important question for mathematicians is this. When we try to add the elements of this series, is it even possible to do so? This is the core issue in infinite series. Infinite series come in two types. The first type consists of series whose terms shrink as we move forward and get closer to each other, such as 1 plus 1/2 plus 1/4 plus 1/8 plus. The final result of this series approaches a specific number, and the changes become smaller and smaller as we add more terms. For example, although this series is infinite, its sum ultimately approaches the number 2. This type of series is called a convergent series. The second type, my dear friend, consists of series whose numbers do not shrink. They either remain the same or grow. Therefore, we can never determine their final sum. This type is called a divergent series, the opposite of convergent series. These series do not come together. The deeper you go into them, the more scattered they become. That is their fundamental problem. Now let's go back to the year 1703. There was an Italian monk, mathematician, and philosopher named Guido Grandi. Grandi said, I have a way to deal with a series that neither grows too much nor shrinks too much, and you can extract a result from it. He presented a problem related to this type of series and solved it in a way that seems simple on the surface, yet caused enormous controversy and debate for nearly 150 years. Let's see how he did it. He said, let's take an infinite series and call it S. S equals 1 minus 1 plus 1 minus 1 plus 1 to infinity. If I ask you to calculate the value of S, you'd say, it depends on where we stop. If we stop at the first two terms, S equals 1 minus 1 equals 0. If we take the first three terms, s equals 1 minus 1 plus 1 equals 1, we notice that if we stop at an even number of terms, the sum is always 0. If we stop at an odd number of terms, the sum is always 1. Now, since we say that s equals 1 minus 1 plus 1 minus 1 to infinity, let's subtract s from both sides. The left-hand side becomes 1 minus s. On the right-hand side, when we distribute the negative sign, the signs flip, 1 minus 1 plus 1 minus 1 plus. Doesn't this expression remind you of something? Exactly. It's s itself. So when we say 1 minus s equals s, we end up with s equals 1/2. A very strange result. We're summing a series made only of ones and zeros, no halves, no fractions, yet the result is 1/2. Where did this half come from? Since the series oscillates between 1 and 0, the final result, if we must represent it, is the arithmetic mean of 1 and 0, which is 1/2. Think of it this way. Imagine a dark room with a light bulb that we keep turning on, off, faster and faster until we reach the maximum possible speed. Someone standing outside the room observes. What will they see? A lit room or a dark one? Grandy's answer is they will see the room half lit, not fully bright, not fully dark, something in between. Now, my dear friend, remember this result. Grandy's series equals 1/2. Now, suppose there's another series, call it S2. S2 equals 1 minus 2 plus 3 minus 4 plus 5 to infinity. Now add S2 to itself, but shift one copy by one term. You get 2S2 equals 1 minus 1 plus 1 minus 1, which is exactly Grandy's series. So S2 equals 1/4. Now we're ready. Let's define S3 equals 1 plus 2 plus 3 plus 4. And now S3 minus S2 equals 1 plus 2 plus 3 plus 4 minus 1 minus 2 plus 3 minus 4. So S3 minus S2 equals 1 minus 1 plus 2 plus 2 plus 3 minus 3 plus 4 plus 4. So S3 minus S2 equals 4 plus 8 plus 12. Factor out 4. S3 minus S2 equals 4 times 1 plus 2 plus 3 plus 4 plus 5. So S3 minus S2 equals 4. S3, which is S3, equals minus 1/12. How can a sum of positive numbers that keeps increasing endlessly end up, in the end, as a negative number? Perhaps, my dear friend, this tells us something deeper about the very nature of numbers themselves. Perhaps numbers do not move in a straight line, but rather move in a circle where the negative and the positive meet at 0 and then meet again at infinity. If you reflect on this idea, you'll find it resembles many things in life, from electrons orbiting the nucleus of an atom, to galaxies revolving around one another, to evil giving birth to good, and good that may turn into evil. Negative and positive numbers, despite moving in opposite directions, may actually be rotating within the same circle and might meet at the same point, even though at the beginning they seem to be heading in opposite directions. The idea that you don't know exactly where the negative sign appeared in this impossible journey of adding numbers, even though all the numbers were originally positive, closely resembles the miracle of life and death. I always ask myself when I see someone who has just died, what is the difference between this man a few seconds ago and now? The heartbeat can be replaced by machines, and breathing can be replaced, but life itself cannot be replaced. We do not know when life entered the fetus in its mother's womb, nor do we know when it left the body of this person who has died. Many questions bring us back to Taoist philosophy and to the symbol of yin and yang, where the negative and the positive are intertwined and can never be completely separated. Doesn't this resemble life itself? We are born knowing with certainty that we will eventually die, but no one knows what will happen in between. We know the journey begins with life and ends with death, but we are ignorant of the details of the path. We know, for example, that roughly half of humanity is female and the other half male, but we don't know who will marry whom.